Hi everyone, it's really a pleasure to be here, and thanks for the warm intro. And yeah, that was a fun article to write. Let's melt Facebook into the community. So today I'm going to talk actually about an AI Commons and how we can get there. And I'll just start with, earlier today, Rutger mentioned someone who's one of my new heroes, Greta Thunberg. And she talked about how in 2075, she might have children, and how can she explain to her children how we as thinkers and workers in the world let the planet be destroyed by the climate. And I love that she says things so bluntly, and that she actually is raising, in Berlin, every single week, there are 10,000 students going on strike every Friday saying, we need a future. And so you can generalize this idea towards we need a future. There's the planet, we need to get straight on that, but we need overall sustainable development. And actually, over the last number of years, the UN developed something called the UN Sustainable Development Goals, the SDGs. There are 17 of them in total, and including no poverty, zero hunger, but also the ones that deeply matter for the next 12 years. That's the timeline we have that Greta has pointed out, towards clean water, affordable green energy, and basically not screwing up our planet. And so the UN rolled these out as goals, and it's basically become the KPIs for the United Nations. The dozens and dozens of UN agencies are getting behind this, as well as many of the NGOs of the planet and governments, et cetera. So for once, we actually have a target to go for in terms of good for the planet. You can actually measure these. There's more than 180 different measures towards seeing how well are we doing towards eradicating poverty and hunger. So this is really kind of a nice direction to go. You might qualify it overall as sort of a direction for good, as opposed to, say, social media turning us all into, shallow thinking zombies. So that's kind of an AI for bad. But we might ask, rather than stopping just the AI for bad, can we use AI for good? So rather than just getting rid of the negative narrative, let's actually have a positive narrative. Can we use AI to drive towards the UN 17 Sustainable Development Goals? It's a great question. And actually, people have started to ask it. So people have started to look and say, hey, can we use satellite imagery to start to track deforestation and how deforestation can be restored via running water and so on? And we'll have talks later this afternoon on issues around rainforests, et cetera. So I'm looking forward to that. Or tracking livestock to reduce conflict. It turns out there's some nonlinear interactions there. Microinsurance for crops, and so on and so forth. So can AI be used for good here? And keeping going, I still don't know where to point the pointer to make things go. Or towards smart cities and smart communities. Can we tailor the smart city such that the traffic lights are more optimal to save 20% or 50% efficiency there? And overall, it's towards this goal of for good. And in a long-term vision, AI has great potential to bring us abundance, to reduce costs by not just 10% or 50%, but by 90%. What does it look like? Because if we're not careful, all the efficiency gains will go into the hands of a few. But if we are thoughtful about it, then maybe we can channel that to spread the benefits of AI to the whole planet. So related to this AI for Good movement, there's actually now a summit. It started first in 2017. That was its first year. Last year, 2018, was the second year. And it's continuing to happen. This is actually spearheaded by the ITU, which is the Telecommunications Union of the UN, as well as X Prize Foundation, ACM, and so on. And at this summit, it's actually not that many developers. It's a lot of sort of NGO-type policymakers and so on. But they've been asking, what can we do to help drive AI for good? And I was at the good fortune to start to get involved in this, and I realized this is a really good platform to engage sort of the policymakers at that level. But they were actually looking for a platform, and they're looking for technology, and they're looking for people to help them actually implement this. So overall, I guess we can summarize, can AI help towards AI for good? And the answer is yes. I gave you a few examples. There's actually quite a few out there. But there is still a challenge. We haven't seen massive impact yet. And the reason is, it hasn't scaled yet. There's a problem. There's all these people that have the AI-type problems that they want to solve, whether it's related to tracking deforestation or cattle movement or science in general. And then there's the problem solvers, the data scientists, the AI researchers, and so on. And the AI people, they tend to be, coming out of a university or, starting their first year of their PhD, and they're given a data set and they just work with it, right? Maybe they're given ImageNet, which is famous in the AI world for computer vision, or before that, UCI, and other sort of problems like that, OpenML here in the Netherlands. So there's that, but then the problem owners, they're not really talking to them. It's actually fairly disconnected. So there's this gap. And this gap really needs to get resolved. So if we can actually help to resolve this gap, maybe we can scale up AI for good and start to have a massive impact on the UN Sustainable Development Goals, a massive impact on AI for good. So if we flesh out this ecosystem, there's not just the problem owners and the problem solvers, you've got the data owners. And it turns out that modern AI, especially regression and classification, loves data. We hear about deep learning and all that. That's just one class of AI models. But this is the class of AI models. It's sort of a modern neural network that's just really, really big. Take the neural networks of 1962 and apply 50 years worth of Moore's law, and that's how you get deep learning. And that's for data as well as compute. So what's happened is actually people have said, let's not train on just 10,000 data points. Let's train on 10 million data points or even 10 billion data points and make this AI model that's actually accurate enough and feasible enough to run with. So that's the data owners. And they're usually talking to the problem owners a little bit. And then there's also the storage and compute for the data itself and the problem solvers trying to run the storage and compute. So this fleshes out the ecosystem a little bit. You've got the problem owners, the problem solvers, the data owners, and the storage and compute. And at the end of the day, what we're really trying to do is get the problem solvers to work with the problem owners, et cetera, to solve these problems. So imagine if we can actually connect these folks with some sort of connective tissue, some sort of public utility network, right, where we've got these data owners, the storage and compute, the problem owners, all feeding in to help the problem solvers solve those problems, to build these AI models, to help predict cancer better, to help deforestation, and so on. What does that look like? Well, enter blockchains, right? So we've actually had public utility networks for a long time. The waterworks, right? We go to a tap, we expect water to flow out of it. We expect to have electricity. We've had electricity for more than 100 years. It's assumed it's basically a fundamental human right? Sort of in Maslow's hierarchy. It's food, clothing, and shelter, but food is coming from taps and just sort of there to us. And clothing and shelter, electricity, internet even, is starting to, internet really is a public utility network. And Bitcoin, like the previous speaker, has actually emerged also as a public utility network. And this is kind of an amazing thing, right? It's this thing that no single entity owns or controls. It's a utility for the public, and it's a network, as in it's many, many agents joined together talking. So blockchains themselves can be rolled out as public utility networks. These are really the permissionless ones. So then, for the substrate to connect these, let's have a blockchain-based public utility network for the AI commons. That's the general idea, right? If we do this, we can help to catalyze the connection from the data owners, the storage and compute, the problem owners, to the problem solvers. Now, of course, this is a very, very general way to think about it, but we can drill in. So let's drill in a little bit and unpack this. So this is probably the most detailed slide and way too many words for this conference, but I'll flesh this out a little bit. So the data owners on the far left are interacting to different service provider front ends. They're basically supplying data, saying, hey, here's data. And there's also people supplying markets for storage and for compute, right? And what are they getting in return? Well, for the priced stuff, they can be getting paid. But also, imagine if there was block rewards for people supplying data to the commons, right? Because overall, what we're really trying to do is we're trying to spread the benefits of AI to the world. And to equalize the opportunity to access AI, it's really about spreading data, making data accessible to a much broader set of people. So that's really what the far left is, the green. In the middle, there's also the idea of an AI commons front end. So the problem owners are engaging back and forth with an AI commons. This is where people specify the problems. And they're working very, very closely with the problem solvers because there's sort of this back and forth between solving the problem, defining the problem with more clarity, et cetera. And those problem owners are defining the problem in something called Jupyter Notebooks. Who here actually knows about Jupyter Notebooks? Many people? Oh, wow, quite a few people. So as you probably know, it started as IPython, Interactive Python, in about 2010, 2011. and evolved and evolved into something called Jupyter. So it's not just Python, but more stuff. And in the last 2 or 3 years, Jupyter has really grown up. It's actually its own protocol now. It's a thin protocol. It's stateless. But it's really, instead of being a side tool just for analysis at the tail end, it's actually become the center of infrastructure at large enterprises like Netflix. So Jupyter Notebooks are a wonderful way to specify a problem in learning AI. You've got the inputs and the outputs, the sort of goal you're trying to solve, and so on. So imagine if you can specify these problems in a Jupyter Notebook, but then you actually populate this into the public utility network. Then, of course, you've got the problem solvers. They can yank this out of the public utility network and start to solve it. And as they solve it, their computation, their storage, et cetera, can be recorded, the results especially, can be recorded into the public utility network and made available for everyone else. And so at the baseline here in this public utility network, there's really 2 ways to incentivize data. One of them I've talked about very briefly, which is block rewards for the data itself. So I can make data available for free for people to use. So it's free for the consumers, but at the same time, myself, I can get rewarded by inflation in the network. There's also a second way to incentivize data, and that is, if I'm a big enterprise, I'm really worried that if I make my data available out there, people download it, then it's going to escape. It's just going to get copied, and I can't sell it anymore. Or what about healthcare data? Myself as an individual, I've got healthcare data. I would love that it could be used to help predict cancer and Parkinson's and all that, but I'm really, really worried about my privacy. How do we thread the needle between having healthcare data out there for commons usage to build models that benefit humanity, yet at the same time preserve privacy? So what if the network actually helped to make that a lot easier? I'll flesh this out. So this is kind of overall a framework, a stack of what this can look like, connecting the data owners, storage and compute, problem owners with problem solvers. And of course, overall, when you have a commons, if a commons stands on its own, it's actually often hard to make it sustainable, simply because it doesn't have a positive feedback loop of sort of money flowing into the system, value flowing into the system. At the same time, if you have just something that's just for profit, then the benefits will flow into the hands of the few, and it might not grow. But it's my hypothesis that if you actually have this sort of yin and yang of a for-profit with the 4 commons at the same time, then they can help each other, they feed each other. So imagine we can actually catalyze the commons and the profit making, and we have this substrate for 1,000 marketplaces to bloom. So marketplaces for buying and selling data, but not just raw data, it can also be cleaned data, it can be neural networks themselves after they were trained, and other AI models, FFX, et cetera. So at the top, you can see the blue and the orange, kind of a bit faded, I guess. There's people that have the data and want the data. And in between, we have a whole bunch of data marketplaces and the commons. So this is the vision. So imagine the substrate makes it really easy to build these marketplaces. So I talked about block rewards to incentivize the data supply. And the idea of the block rewards, once again, is add to the data commons and make money. And kind of related to this, Stuart Brand, famous futurist thinker, et cetera, he has a quote from a long time ago, which is, "Data wants to be free, and it also wants to be expensive." And there's been a lot of attempts to try to crack this problem over the years. The reason data wants to be free is because of the physics of bits. You can freely copy bits throughout the world. It wants to be expensive because the creators of the data need to get paid to feed their families. So how do you thread that needle? Well, here's one way. One way is you put the data out there for anyone to download, so the people that are downloading and getting the data, they're getting it for free. But the people that are serving up the data can feed their families because there's inflation. There are block rewards if you actually spend the resources to help serve up the data. So that is a way to resolve this long-standing problem, the Stuart Brand problem, of data wants to be free and expensive. We also want to incentivize data in a second way, and I hinted at this a bit before. We want to supply this data, especially, say, healthcare data, medical data of myself, and maybe all of you in the room. Imagine if we could build a model of cancer. Actually, I'll just take a rewind. A friend of mine, he's an AI researcher. He's building genetic programming models of cancer. He tells me he's a happy man if he has a data set of 100 people. Yet he's actually using DNA data, so he's got 30,000 input variables and 100 data points. And as you might imagine, that leads to a terrible model no matter what. The best you can do is a linear model with heavy, heavy regularization. But imagine instead, if you're trying to build a model of cancer, and you have 1 billion data points from 1 billion people. And imagine, though, there wasn't one giant data honeypot that people could come in and suck this all out. You know, just like this sort of the Adar honeypot, but it's actually like not out there for people to take. So imagine, though, that you can still, from this set of 1 billion data points, you can actually train models where you can actually predict cancer from that. So how do you thread this needle? And the answer is bring the compute to the data itself. So this is what, and what you need, though, is you need an intermediary that helps myself and each of you to provide your data in a way where you've got this sovereign personal data that you're holding onto. You're giving keys to specific data scientists to actually do their neural network training or to do their AI modeling more generally. And they're also grabbing some algorithms, and then basically, at the heart, though, the training itself happens next to the data. So you've got federated learning among every one of those billion people, or more likely what will happen is you've got 10,000 hospitals. Each hospital has, say, 10,000 records, and then you're across those 10,000 hospitals, you're doing federated learning across that. And by doing this, then you end up with a model that no single entity owns or controls, but it can be queried by data scientists to make predictions, right? So we can have models to predict cancer and Parkinson's and Alzheimer's and all this across 1 billion people. This is a radical change compared to before. So instead of talking 30% accuracy, or error, sorry, what if we had 1% error? What if instead of detecting cancer 6 months in, you can detect it 6 days in? That will make a radical change to the benefits and the survivability. So the key trick here is to bring AI compute to the data, with the middleware layer being this public utility network. That is actually critical. No single entity can own or control this. Keeping going. Still have to figure out where to point. It's just kind of like random sampling here. Here we go. So with this public utility network, it looks like I have to point here. OK, let's try. Framings. There we go. That's the one. So the next features, that's where you point, OK? So there's a few ways to think of this. One of them is think of this overall, this public utility network, as an AI compute pipeline. So back in the day, there was MapReduce, and Google built this internally in order to basically speed up the computation, to parallelize computation across many machines. On the heels of that, there was Hadoop, which became a public version that many people could use. Still hard to use, so then along came Apache Spark, and ever since there's other open tools too, like Flink and Airflow and so on. And the core of these is basically an AI compute pipeline. In comes some raw data, and you've got then you do some cleaning via compute. You've got the trained data that you store, and then you train the model, and then you store the model, and then you have some new input data, and then you finally output some predictions, right? So some sort of overall AI compute pipeline. Imagine if you have, and overall, there's a system that helps to orchestrate this, right? So this is what an AI compute pipeline is about, and this substrate actually needs to manifest this in order to bring the compute to the data. So this is an example. You have the different providers, AI compute, like data providers, algorithm providers, and so on. I've got this now. The pointer is really working now. So overall then, if you think about who's providing the data and who's providing the compute, well, what if you open that up to the world and said, OK, in this overall compute DAG, this AI compute pipeline, we've got a whole bunch of organizations and people supplying data, right? And it can be from Web3 networks, like Filecoin or Storage, or it can be from Web2, like things out of Amazon S3, or it can even be individual organizations. So there's these tribes, if you will, providing data. You've also got tribes providing algorithms, whether it's out of scikit-learn, one of the top ML frameworks, or specific algorithms from competitors in Numerai, et cetera. And then we've got the compute tribes, the people doing the compute, and you can have now, once again, Web2 networks, like Amazon EC2, Web3 networks, like Golem or TrueBit, as well as computing behind the firewall if needed. Storage, similar to the data, but once again, there's the people holding the data and the people storing. And finally, analytics, et cetera. So now you can think of this as an inter-service network, a network where there are services provided in this overall compute DAG. Once again, this is necessary for an AI commons when you're actually trying to bring compute to the data itself. Overall, another way to frame this is that it's a network of networks. So later on, we'll have Yuta from Federated talking about Polkadot as a network of networks to connect Ethereum and Bitcoin and so on. And that's a wonderful paradigm. if you're a crypto person, you can think of what we're doing in Ocean as sitting on top of things like Polkadot, where it's sort of L2, whereas the Polkadots of the world are L1. But if you're an AI person, if you're just building AI tools, then it's simply an L1 network, where it's a network of networks simply for the AI stack. Another way to think about it is Ethereum and its brethren are really targeting the web developer crowd, if you're trying to build websites and systems like that. And in the web world, though, that's sort of one stack. You've got JavaScript and you've got Node.js and so on. In the AI world, you actually have a completely different stack. And so what we're aiming for with Ocean is really to target this AI stack, where we're drawing on things like Jupyter and Apache Flink and these sorts of things in order to actually make AI itself decentralized to spread the benefits of AI. I'll skip that. So overall, you might ask, given that you guys are developers, what does this look like if you're an end user? And then also, as a developer, how do you get in? Or many of you are developers. I should ask, actually, how many of you are developers here? Wow, great, good, half of you. And the other half are aspiring developers, right? No, all good. So user experience, I talked about this a bit, but overall, there's already an existing AI stack. In the last 2 or 3 years, Jupyter has just massively taken off. So imagine if you're a data scientist, an AI person that is building with Jupyter. Imagine now you can simply start to hook in crypto, Web3. So we actually have a system running that hooks Jupyter to a MetaMask wallet. In fact, any any Web3 wallet, because it's using the Web3 library under the hood. So this is very nice. So you can basically now grab data, publish data, even earn block rewards, et cetera. And the overall paradigm is to keep the data science tooling. Why throw out that existing stack? And then every data set is an asset. And therefore, also, every Jupyter notebook is an asset, right? And when I say asset, I mean something that can be framed as a non-fungible token, for example. And you can have service execution agreements around that, one thing leading to the next, leading to the next. And sort of as a data scientist, when I give a talk to a room full of data scientists or AI people, I talk about how they get new benefits. And there's really 3 main ones. Way more data. I talked about this via the data commons. And enterprise data without data escapes, right? And how do you do this? It's on-premise compute. So if you're an enterprise and you have tons of data, you're asking, how do I monetize this? Yet you're worried about it escaping. The answer is bring the compute to the data, and then let the compute happen, and then basically sell the access to the data, but only after it's computed, right? So that's a way to thread that needle. The second is provenance in the data and AI training. A friend of mine used to run data at SoundCloud, and they had built an amazing neural network model that did very nice recommendations, but they couldn't use it. The reason they couldn't use it because they had some data sets where they didn't know where they came from. So it would have been illegal to use it simply because they didn't know the provenance, the origins of some of those data sets. By the way, with GDPR, now you actually need to explain every single AI model that you use. So GDPR might end up being a mandate for explainability in terms of provenance and so on. And finally, if you're a poor, aspiring PhD student, you invent a new algorithm, imagine if you can actually help to monetize that right away. So you come up with a cool new data set, a cool new algorithm, you label some data. This is a way to start to get some more income that way. And of course, for generating and making data available itself for sort of this context of generalized mining. So I've talked about this overall vision of AI for good towards an AI commons and really towards sustainable development for the planet, to help make Greta proud. And so I'm going to start to give a few applications here of what this can look like. So one of them is water quality, and this is something that IXO Foundation is working on. We're working with them on it. So in this case, there's forest restoration and to help water supply. And you want to understand how much can forest restoration help the water supply. Satellite data is super useful for that, and ideally the satellite data is out there in the commons. So this is one of the use cases that IXO is working on, and imagine that all the satellite data, as well as the forest data and so on, is actually all available for the whole planet to see and to use via basically a unified API. And also the people who are supplying that data to make it available, there's actually block rewards for that. And that's actually, one of the use cases. Another one, I guess I've talked about this briefly, the idea of if you have a data set across the vision, 10,000 hospitals, then you can predict diseases better. We're working closely with a company called Connected Life out of Munich, which is actually doing this for Parkinson's disease. And so this, of course, you can connect data sets across borders, across hospitals, across different jurisdictions, and promote research collaboration more broadly. Another one is this WEF spin-off called Grow Asia, and it's really helping farmers to allocate fertilizer. So I grew up on a farm in rural Canada, and every year we had a fixed budget in order to fertilizer, how much fertilizer do we put in, and at the bottom of a hill, you actually have water that flows there, so you don't need as much fertilizer. Near the tops of the hills, the water flows away from rainfall, so you don't need as much fertilizer, so you need more fertilizer there. So how do you actually figure out the optimal allocation? And an answer is more data, more AI. And so, the places that would need this the most are the people with the tightest budgets. And this is, in this case, Grow Asia is targeting Asia. Another thing, who here is policymakers from the government or from kind of related NGOs? Just one, two? Okay, we've got a few. Okay, so if you're a policymaker, you're trying to do things like, okay, how do we promote GDPR? How do we resolve this tension of AI benefiting and therefore wanting more data, but at the same time wanting to preserve privacy? And so imagine if there was kind of a way to help address this, and this is actually what we're working on with the government of Singapore, their data authorities, where by bringing the compute to the data, it can help to resolve this challenge. You actually get the benefits of sharing data at the same time as addressing privacy. So GDPR is met. And in fact, it's our dream that we won't need as many things like GDPR in the future because it will be naturally a part of our substrate of civilization, where there's just this public utility network for all that makes this possible. Everyone owns and controls their own data. They give permissions to people as they see fit. They revoke permissions as they see fit, right? I deleted my Facebook a few months ago, and it felt great, by the way. And I have to trust Facebook that they deleted it. Of course, there's laws that mandate that if they don't delete it, they can get sued. But imagine the future where as soon as you delete, it's simply more revoking permissions for people to access your data. And that's much cleaner and more straightforward. And by doing this, it actually, of course, reduces the data honeypots and stuff, too. We no longer have the hacks like Equifax, et cetera. And I guess, towards conclusion, there's now a movement that has grown out of the AI for Good movement at the AI for Good Summit, something called the AI Commons, where many top AI researchers, as well as UN agencies and the AI X Prize folks, are driving together towards this AI Commons. And basically, they're driving towards working with us as this common substrate. Those of you who are developers here, you might ask, okay, how close are we to reality on this? And if I was giving this talk a year ago, I would have been like, we've got a lot of work to do, but I'm happy to tell you now we're much, much closer. There's docs.oceanprotocol.com. You can go there and start building now. There's a testnet running. If you're a data scientist and you want to start playing there, you can go to datascience.oceanprotocol.com and click Get Started, and you can actually kick off a Jupyter Lab instance. So it's basically your own Jupyter notebook that's being hosted. And this is an example of the notebook just getting going there. So this stuff is starting to get real. Within a matter of months, the mainnet will be out. So we're quite excited about that. And so this is an example of getting going with an ocean node. And you can see that we've got a pretty dolphin. We like all sorts of ocean characters, dolphins. I especially like jellyfish. That's ocean. So overall, the point is, yourself as developers, I encourage you to check out docs.oceanprotocol.com especially, and then everything else leads from that. So to conclude, I've talked about this broad goal of the sustainable development, the UN SDGs, and AI for Good as a means for AI to help drive the SDGs. The question is, how do we scale that? And the answer is, blockchain can make a big difference, a blockchain public utility network for the AI Commons. Thank you.